Hello everyone, this is Ajay Kumar. Today we are going to see a powerful design and evaluation solutions for a textile machinery manufacturers. So for the past weeks we are seeing a different vertical industries like food machinery industries and special purpose machinery industries SPMs, and also the different verticals like mold tool and die. So these are the variations, what are the designs we follow. So we can easily able to communicate the designs through a SOLIDWORKS. We have a potential and powerful tools such as part design, assembly design, and the generation of detailing drawings. So in today's session we are going to see how a validation and a design can be a best providence for a textile manufacturers through an application of SOLIDWORKS. So this is today's agenda. We are going to see like error-free manufacturing assembly sequential process and the evaluation stage, how we are across the designs, and automation of designs to reduce the design time, and evaluation of the products. So the next slide is how the most common challenges we overcome through a 3D CAD designs, and the number of reworks again and again may occur by following the 2D drawings and the thumb rule method. Since an experienced people can follow the thumb rule method, so that they spend a lot of time in the number of reworks and the wastage of materials can be more, and it will be a difficult task to meet the project timelines, so that the return on investment will be get later on. But whereas in SOLIDWORKS 3D CAD, these challenges can be addressed one by one, and most of the common challenges to address the industry people is to achieve the return on investments. So SOLIDWORKS 3D CAD is one of the asset software, so that we can be able to achieve the designs what we are manufacture in real time, and the detections, the assembly errors and the drawing generations, etc. like that. So the basic building block of a 3D model is a normal 2D sketch. So in normal 2D sketch we used to follow the 2D drawings, and there will be an imagination in conversion of the 3D models. But whereas in 3D CAD, instantly we can convert the 3D drawings in the formation of some of the assemblies of 2D drawings in generated in an AutoCAD or the 2D draft sites, etc. like that. Actually, you see on the screen, this is one of the textile machinery parts we are manufactured in a real time. So this is one of the machinery which has a constructional manner with different kinds of parts like the shaft, the gears, and the bearings with supporters of the two shafts in down the corners, and the different kinds of toolbox. You see that the nuts and bolts, the washers, etc. like that. So these are the meshing powerful. We have a ratio calculation of the gears and the fundamental strength, whether it would stand the load on the continuous load, etc. like that. So for an example, I would like to create a new part for this such a kind of assembly manner. So before that, I am just making of the assembly understanding. I would like to show you how a part design will be more convenient for the 3D CAD designers. So here, as I told, the 2D drawings can be easily generated or converted by using of the 2D to 3D converter without any creation of 2D drawings. So or else I just want to design from the scratch, that also I can able to do a designs with the using of simple sketches. So here, since SOLIDWORKS is a 3D parametric software, we can able to make any changes then and there. So that is the ultimate aim of the SOLIDWORKS 3D CAD, to reduce the design time. So that is the main part that we are concluded in most of the designs and showing of the verticals, that we are addressing most of the challenges like that. So here you can able to see how simply I am just making a sketches in controls of the design of 2D drawings. So here for an example, after I am just designing a sketch, the dimension of the 2D drawing is similar to an AutoCAD or the draft software. So here for example I just want to maintain a 135 mm of the height between these two, and the distance between the adjacent sides of these two circles will be a maintaining of the distance as 80 mm, and the diameter of these circles, let I say for an example just 40 mm, and this like as an 65 mm. So here you can able to see that the blue sketch indicates me that the sketch is underdefined, and we can able to easily identify whether the sketch is be controlled within the throughout a 3D design models. So here for after completing the 2D sketches, I am just skipping directly into the conversion of the 3D models. Here you can able to find that I just want to convert these 2D sketches instantly in a single environment. So here I just want to make a contour of this part, and with a thickness of this part, let for an example just 30 mm, and here you can able to see that uniformly changes of this model. And the next I just want to make these extrusion cuts. So here you can able to find that I am just using these seamless sketches for an example, and this time the boss extrude. So here the directions can be easily controlled with different manner. You can see that the right hand side the end corners throughout the faces like that. So instantly I have been created a 3D model here, and after completing this I just want to avoid the sharp corners so that I can able to place the fillet so that the avoidance of the part can be easily done. Here you can able to see that the pink color shows me the wherever the fillets necessary. We don't have to spend our own time to give a fillets for each and every edges. So simply I am just choosing the places where I just want to make the fillets. So I am simply choosing the edges here, and the allowance of this the fillets may be as a 5.5 mm the fillets, and simply clicking OK. Here you can able to find that I have been completed a model, and before that I just want to show you that how the extrusion cuts. Still not I have been sure how a model can be extruded. In case of any extrusion cuts we just want to make, that also we can able to do, and the relations between the two sketches, that also I can able to do. So here for an example I just want to make the 40 mm diameter similar to this. So these two sketches can be suggest me with different kinds of relations between the two entities. For an example, it should be a co-radial or the tangency or equality like that. If I for an example I just want to give an equality, it takes me the diameter of 40 mm, but I just don't want to give a equality of that. I have to mention the dimension of like 25 mm. So after completing this you can able to find that the preview, the yellow color mark, you can see that here the moving the parameters, that I can easily able to understand that the extrusion cut has been away from the surface. So here you can able to find instantly I have been finished the 2D drawings. So here next I just want to show you how the part setup can be easily created. So what are the manufacturers we make a communicate? It's definitely easy understandable for the manufacturers is to understand the 2D drawings, so that the 2D drawings can be easily generated within a matter of minutes. See how fast I can able to create a 2D event. So here on the right hand side you can see in the view palette that the every view has been generated automatically. Here I don't want to manually design any one of the views. So here just dragging and dropping the which views we have to design is the only possible way for the designers to easily finish the designs very much fast. So the next thing I just want to make a top view for that, and simply dragging and dropping the top view that. And my next option is to create a section view for this part, and creating a section view. In case of any detail view I just want to create, and instantly I can able to create a detail view for that. So and not only that, the dimensions, so making of the dimensions is also a easy manner, so that any changes we have to do, that also we can able to instantly change any designs that across the changes has been happen throughout the designs, the part, the assembly and the drawings. So, and not only that, the blocks, the title block has been filled up with the different kinds of names, the material, the weight, and some of the certain criteria, like for an example, the finish. So what are the finish and who is to check the document. So everything has been updated with respect to the properties we apply here. You can able to see that the numbers, the part number, the revisions, the material, weight, etc. like that. For an example, I just want to make a weight of this component. So instantly I can able to create the different kinds of sets, the stock size, the unit of measures, like etc. like that. So here I just want to show you how, and this design part has been very much useful for the assembly environments. So here actually I just want to create an assembly, I just want to bring back this assembly part. So I'm just making the assembly environment to insert the components and bringing the component here. You can able to see the preview mode that the component has been bring up to the assembly mode. So here I just want to make this part, want to assemble with respect to these two places. So I just making the component to float so that I can able to move the component very much of easy manner. So the next thing I just want to make you ensure that I just want to these two circles want to mate with these two components. So let's see for an example how fast I will assemble this component. Just I want to make these two by using the simply hotkeys. I can able to create a mate between the two components. Here the SOLIDWORKS uniqueness is that the mating between the two components will be automatically suggested, and we as a designer the only way to click OK is the only job. So here the parallel mate, the perpendicular, the tangency. So these are the relations between the two components. So here since it is a two cylindrical components, it automatically suggests me the concentric mate is the best mate. So I am just simply clicking OK is the only job for me, and I just make a concentric to this part, and here you can able to see that these two edges should be a coincident to that. Here I have been fixed at one end, but the another end you can able to see that it is a movable component. So the up and down actions should be a movable component, so that it should be made with the another component, so that I can able to make any clearance between the two components can also be identified with using the evaluation tools like interference detections, the collision detections, and the whole misalignments like that. So you can find that the evaluation tools, as I told here, I just find the deviations, but how much deviation we can able to check by using the whole alignments and the clearance detections between the two components, either it is a shaft or the bearings, and the clearance can be easily evaluated. And not only that, the assembly drawings with respect to the bill of materials, the generation of 2D drawings, that also we can able to create within a matter of minutes. So from the scratch of the design and to reaching the product to the end users, so what are the areas we cover, that everything can be easily done through a SOLIDWORKS. So SOLIDWORKS is not only a 3D CAD software, we can also build technical documentations and to create a blog contents, the marketing contents, and also in case of any animations we need to do, that also we can able to generate the animations, and that can be shared through a mobile phones like that. So in different kinds of formats like MP4, AVI, and different kinds of formats that we share among the mobile phones. And not only that as of every production people that we face a difficult thing, and we have any idea that how large assembly file that can be designed. So SOLIDWORKS 3D CAD has a potential to evaluate the performance of the design, so that how long the large assembly file, how long the large machine is, doesn't matter for the SOLIDWORKS. So the large assembly file also can also be designed. The machine how much long is not a matter. So here you can able to find that the different mechanisms like the gear, the shafts, and under the beneath of this part you can understand the different kinds of toolbox. In case of any belt we just want to create, that also we can able to create instantly. So here the between the two sides I just want to create a belt, so that instantly I can go to the belt or chain creations and choosing the two shafts, you see instantly I can able to create the length of the belt. And what is the exact length, I just want to create or purchase the belt for this mating of these two components. So here SOLIDWORKS suggests me the best suitable length for this is 15W1 mm, so that we can refer the standard tables, the design tables for the manufacturer. So we have according to that the 1518 mm length or 1508 mm length we can be suitable for the standard belt size. And next you can able to see that yes, 2D drawings we have been generated within a detailed drawings, that the automatic placements we can be done, and the assemble parts how we do in real life as is shown in the live screen. And the also the evaluation of the products, like the identifying the error within a design stage, so that the number of scraps, so the number of reworks can be reduced. And in case of animations, in case of any generational assembly drawings with respect to the bill of materials, so here you can able to find the bill of materials, the item number, part number, and the distributor, the quantity you can able to find. And the balance with respect to the bill of materials can also be generated. And next we should focus on the design automations. So this is one of the powerful tool in SOLIDWORKS that has a uniqueness for the users to understand the whole designs. And not only that, the designers can only not to design, also the sales, the marketing persons can also carry the designs to show the presentation in front of the prospects or the customers to take an order immediately in the global market. So here the automations can be achieved by using the controlling of the numerical values only, not to design again and again. And as I told, the designs can be carried for the presentations and automate it by, and even though your salespersons can also be automated. So here the controlling of the designs can be achieved by numerical values, not the whole designs. So the next thing I just want to show is the product validations. Here the product validation can be easily done with respect to the which design is better, and what may be the product life, or how long it will be withstand my load, where the maximum load takes place, and what will be the where the failure begins in either in a part or assembly sections. So if it is a part, how long it will be withstand, and what will be the maximum stress and the deflections, and how much times it has been withstand my load. So these everything can be easily done with respect to this simulation software. So here for an example, here the maximum load carries with respect to this part. So I just want to evaluate this part, how I will be evaluated in my real-time environment. So here I just want to make an evaluation of this part. For an example, I just making a new study of this part, and the static analysis I have been preferable to do this. So here you can able to find that the different kinds of sets and the different sets of materials. The SOLIDWORKS has a set of database for the materials are inbuilt up to 500 category of materials, and subclassifies has been preferable in SOLIDWORKS 3D CAD. And not only that, the each material has each properties, so that the in case of any research and development of this process, and to know the properties of the each material can easily review within a software itself. So for an example, that is an ductile iron which I am going to manufacture. So instantly I can able to change a ductile iron and can also be easily evaluate the weight of this component. So here you can able to find that the 350 grams of this component is with respect to the ductile iron which I have been applied. So within a design stage I have been evaluate the weight of this component. The real-time scenario, how long we make fixtures of these designs, like either it is a fixed geometry or the roller slides, that one side is fixed and another side is movable, and with respect to the bearing fixtures like that. So here for an example, I just want to make a fixed geometry since we are arrested these two ends of this to the shaft, the roll of the plate. And the next thing, I just want to make an applying of the force. So here the top face, I just want to preferable to apply the force, and since it has a force which acts upon over there, and the force may be a for the torque, the pressure, or the gravity, etc. like that. For an example, I just want to make the application of this force with respect to here of 1500 Newton, and just simply clicking OK. So my next job is to run a design so that the machines can be created automatically with respect to the number of split ups has been done, and the discretization can be done with respect to the creation we do. So here you can able to find that the instantly the design changes. You can able to find that the red color indicates me that that is a critical level, and the blue color indicates me that is a safe levels. So here you can able to find that the deformation of these stresses. So how long these stresses, the load acts throughout the body, can be easily created by using the animation tools. So you can find that the stress, the maximum stress creations. Here the load applies with respect to the supports, the fix I have been created. So the maximum deformation you can able to find with respect to the indication of red color. And not only that, the factor of safety. So the factor of safety here, I just make the two fixtures, and 1500 Newton I have been applied. The 2.8 times it can withstand my load. And not only that, the displacement. So is the maximum displacement of this 1500 Newton is my 0.5 mm. And here you can able to find the color coded forms. And in case of any MAR, is the maximum load carrying capacity, maximum load carrying area, you can able to find by using the inside plots. So here the blue color, wherever the blue color indicates, shows me there is some maximum load carrying area. So that I can able to reduce my thickness of this part, or to add my thickness of this part. So the reports can be easily generated with respect to the Word document. So the everything you can able to create within a matter of minutes, or else in case of any comparing the results with respect to the different iterations, what will be the 1500 Newton for the ductile iron and 1500 Newton for the cast iron, and etc. like that. Or for the ductile iron, I just want to make a 1500 Newton and 1200 Newton, 1000 Newton force. So what will be the different load carrying area for these three kinds of the forces I apply. So these are the design optimizations can also be done through a SOLIDWORKS simulations. And not only that, the optimizations with respect to the material we do, and the goal settings, weight to reduction of the weights, or the thickness, should I maintain this thickness, or should I have to increase or decrease the thickness of this part. So at last we are end of the session. The solutions that has been addressed through SOLIDWORKS is, as I told, in case of any 2D drawings we have like AutoCAD, the DWG formats or the DXF formats, so we can be able to generate the 2D DWG files directly into the 3D environment, or else we have to design from the scratch. That also we can able to do. Any design changes we can able to update then and there. Any design changes can be done then and there, and the automations can be done to show any errors while assembly. That also we can able to identify the errors while assembling in the design stage itself, to reduce the scrap and reduce the prototypes. And so here I just want to show you small statistics about the SOLIDWORKS, how it benefits you. So currently we have a potential customers throughout the global area, and they are feeling proud that using our SOLIDWORKS that can be increase the productivity time up to a 35%, and just in the meaning of the textile industries. And the material wastage, the main thing is the material wastage, since the GST has a great impact throughout the Indian market as well as the global market. So the material wastages can be easily reduced, and the reductions can be happen up to a 20 to 40%, and the prototypes reduction of the prototypes and its cost. So on the right side you can able to see the chart. The committed cost was the incurred cost. So the cost of architecture from the design and up to the productions, you can able to find the lifetime of this product cost. So the committed cost will be a greater on throughout the design process, like the manufacturing process, and the incurred process you can able to find that from the process planning it has a saturated, the peak cost can be occurred only on the production cost. So whereas in SOLIDWORKS applications we can able to easily control the cost and make your project in a successful manner, and can able to meet your timeline, project timeline, so that you can enter into the global market very much fast. So guys, in case of any queries regarding this presentation, you can contact us through an email mktgmarketing@aegis.co.in, or else through a mobile call 94454244704. You can reach us at any time for any queries regarding this session or regarding a 3D CAD software. Thank you.